right, so these are just solving rational equations again today, but a little bit more challenging ones. Here's what I would tell you to do. We could just solve this like a proportion, cross multiply, divide. You'd end up with a quadratic. What I would have you maybe look at before you do that, see if you can factor anything, which you can't in the fraction on the left side. But on the fraction on the right side, the bottom of that, I have x squared minus 9. Can anybody think about how to factor x squared minus 9? Like two sets of parentheses, what would it look like? Do what? It's square, yeah, it's a difference of squares. So like multiply to get negative 9, add to get 0. 1 would be x minus 3, 1 would be x plus 3. Okay, now do you guys see those denominators are actually similar? They're not exactly the same, but they're similar. So if I were to do this, what I would need in the first fraction to make it match the fraction on the other side, I would just need an x plus 3. All right, top and bottom. So I'm just going to try to make a common denominator here. If I can do that, which I just did that there, remember, if the denominators are the same, that forces the numerators to be equal. This makes this problem way easier to solve because now I'm just doing 1 times x plus 3 equals 4x. Now you could totally skip that step because if you distribute a 1 here, that's just going to give you x plus 3 equals 4x. It's not going to change anything. Just subtract your x there. You get 3 equals 3x. And so x is just 1. So that if you get a common denominator there, just one step to do that, it is way easier to work with than if you tried to cross multiply. You would get a quadratic in that situation. You get 2 answers and one of them wouldn't work in the original problem is what would happen if you did it that way. So you can still solve it like a normal proportion, but I would tell you this is way, way, way faster. Is anybody having a question about what I did there? Okay. Now I'm going to do kind of the same thing with this question. So I have 4 over 3 times a plus 8, and I would not distribute the 3. Leave it in factored form. That'll make it easier to see what you might need to get a common denominator. What I would do here, I would put this 2 over 1. And I'm going to notice I have an a plus 8, just like I do in this first fraction over here. So the only thing I'm missing here, if I wanted a common denominator, would just be a 3. So I'm going to multiply top and bottom of that fraction by 3. Now in the middle there, just the 2, it doesn't have anything in the denominator. I just turned it into a fraction by writing it over 1. So in that case, I would need to multiply top and bottom by 3, and I would also need to multiply top and bottom by that a plus 8. But once I do that, then each one of them has a denominator of 3 times a plus 8. And again, you don't need to distribute that. If you can make your denominators match, which I just did there, then don't worry about that. You can just work with the bottom or the top of the fraction. I didn't have to do anything to the first fraction to create a common denominator, so that would just be 4. Okay, now if you want to skip this step, you can, but I'm going to write this out. So I have to do 3 times 2 times that, whoops, it's an a, not an x, a plus 8. Which would really be 3 times 2 would give me 6, and I'm going to distribute that to that a plus 8. The other side of the equation, this is just going to be 5a times 3, so 5 times 3 is 15, and you just go ahead and write the a next to it. And don't add the 4 and the 6. Okay, that's a common mistake people will make if a question's set up like this. Do distributive property first, because in your order of operations you have to do multiplication before you do addition or subtraction. And so I would get, if I did my little distributive property there, I'd get 6 times a would be 6a, and 6 times 8 would be 48. So here I could put the 4 and the 48 together. So I'd have 6a plus 52 there. And I just have that 15a on the other side. Just going to move the 6a. It's positive, so I'm going to subtract it. This question doesn't end up having a nice answer. So you'd be left with 52. 15 minus 6 is 9. So I'd have 52 equals 9a. And 9 doesn't go into 52. And that actually doesn't reduce either. So I would just leave that 52 over 9 is your answer there. And as long as it doesn't make a denominator 0, then we're good. The problem number there would be a -8, and that's not what we got, so we're good. Is anybody having a question? Okay. Now, I would again encourage you, try to factor this. Okay, these denominators and these first two don't match, right? So I've got an x minus 11, x plus 11, those don't match. Can anybody factor, though? I've got 8 over x squared minus 121. Does anybody know? 120. Yeah, negative 121 is a perfect square. Okay, so x plus 11 and x minus 11. And a lot of times you'll see a question like this. Basically, one of the denominators will be one of the factors. The other denominator will be the other factor. Okay, so to make these match, this one would need an x plus 11, top and bottom. The one in the middle would need an x minus 11, top and bottom. And I wouldn't need to do anything to that fraction on the other side because that already had both of those factors in the denominator. So now everybody's denominator is x minus 11, x plus 11. So once you make them all match, you don't even deal with the denominator, just get rid of it. And for the top, that first fraction, we would just have 1 times x plus 11. In the middle, it would be a plus sign, 1 times x minus 11. And then over here, we would just have 8. Now, the 1 times that, you could just drop the parentheses. If you distribute a 1, it's not going to change anything. It's just going to give you back exactly what you had. So it would just be x plus 11 plus x minus 11 equals 8. Now, in this case, there's a positive 11 and a negative 11 on the same side, so those will cancel each other out. X and x will give you 2x, and then that's equal to 8. Just going to divide by 2. So our answer there would be 4. And then just check real quick, make sure that doesn't make a denominator 0, which it doesn't for this problem. 11 would be a problem, or negative 11 would be a problem if we got those as our answer, but we didn't, so we're good. All right, I'm going to do one more, and then we'll do a couple word problems on the back. Okay, so I don't have this factored here in this first fraction, so I've got a 5 on the top. Can you guys think of, for the bottom of that fraction, two numbers, if you multiplied them, you'd get 12. Same two numbers, you add them, you'd get negative 7. Negative 6, negative 1 would add up to the negative 7, but if I multiplied those would not give me 12.
3 and 4.
It's got to be 3 and 4.
Negative 3.
Negative 3, negative 4, exactly. And you can write them in any order, but one should be an x minus 3, one should be an x minus 4. That's the factored form of that quadratic. Now, if you guys notice, the second fraction I have is 2 over x minus 3, so that already has a matching factor, and that's equal to 5 over x minus 4. That also has a matching factor. So here's my recommendation. Let's just create a common denominator between all three. So this guy would need an x minus 4, top and bottom, and this guy would need an x minus 3, top and bottom. So now all my denominators would be x minus 4 times x minus 3. So if you make all the denominators match, then you just don't even have to worry about it. And deal with the numerator then. So I didn't have to do anything to this first fraction to manipulate that other than factor the bottom. So just 5. I didn't have to multiply by anything to make anything match. The next fraction, we had to multiply top and bottom by x minus 4 to create that common denominator, and I had a 2 on the top. So we'll just have to do a little distributive property there. And then on the other side, I had a 5, and then I had to multiply top and bottom by x minus 3 to get a common denominator. And again, we'll just do a little distributive property here. Okay, do not add this 5 and 2 together. That is, like, don't put a 7 there. You got to distribute the 2 first. You do multiplication before you do addition or subtraction. So this would be 2x minus 8, just a 5 in front. The other side, just little distributive property. So we got 5x, and 5 times negative 3 give you negative 15. If you want, on this left side, real quick, combine your like terms. You got a 2x, nothing to combine that with, but I do have a 5 and a -8, so that would be -3. And then completely up to you how you want to solve it. Like I keep telling you, I like to try to keep my variable positive if I can. So if it was me, I would subtract 2x from both sides. So we'd end up with -3 equal, oh my goodness, I didn't actually subtract that. -3 equals 3x minus 15. And I don't have this set up very good today. I'm going to add 15 to the other side. So -3, add 15 to that, we're going to get 12. And that's equal to 3x. And then just divide by 3. So x would be 4. Okay, now, just real quick, before I would write that as my answer, I would look back up to the original problem. Is that going to create a denominator of 0? Nope. Yes, it actually does. So that you got an x minus 4 as part of your denominator. So even though we did everything right, that's going to be an extraneous answer. So this is no solution. So just before you write down your answer, just look at the original problem, probably actually where you factored it, and just see, does that make any of the denominators 0? If it does, then you might have a situation where you have a no solution. Okay. Now, I promise, these problems are actually, the equations are probably easier than what we've been doing. The problem with any of these application questions is, can you set this up? Okay, so these are going to be rational equations we're going to set up from a situation, and I'm going to try to show you the easiest possible way to do this, okay? So you're not probably going to see this in a textbook because I don't think they do it like this, but I promise it works. Okay, so this says Amy and Sarah volunteered to contact every member of their club, like with a phone call or a text or whatever, to inform them of an upcoming event. Says Sarah can complete the calls in 10 days if she works by herself. Amy can complete the calls in 7 days if she works by herself. How long will it take them to complete these calls if they both work together? Okay, we're going to set up a rate for each of these people. All right, so just in general, a rate for each of these people is basically what needs to be done. And that would be divided by the time it takes to do that activity. So each one of these questions is going to be something a little bit different. Now, they do not give you a number. They don't say, bless you, like you're going to make 100 calls. It doesn't say anything like that. It's just going to say the number of calls can be done by one girl in 10 days, the other one 7 days. Okay, if you don't have a number, or even if you do, here's my best recommendation to you. I'm going to let just the number 1, and you could use any number you want. I'm going to let 1 represent all the calls. And like I said, if you wanted to say, oh, they're going to make 100 calls and use 100 as the number, that would work as well. But I'm just going to use 1 because it makes it a little bit easier to work with since they didn't give us an example. Well, they have lives. I don't know. Maybe they have to make a lot of phone calls. Okay, so the first girl, her name is Sarah. And I'm just going to let 1 represent all these calls that they have to make. And so her rate to do what needs to be done, I'm just going to let 1 be making all the calls. It takes her 10 days. Okay, the other girl, what's her name? Amy. To make all those same calls, it takes her 7 days. So what needs to be done over the time for her, it would be 7 days. And I don't think there's any questions that do this, but you would want the time to be in the same units. Both of these were in days. Okay, now, together, we're going to figure out how long that would take. But it would still be making the same number of calls, which I let 1 represent that number of calls. And I don't know how long it's going to take. That's what we're actually solving for, is their time there. So I'm going to let that be x. Okay, see if this makes sense to you guys. If they're going to work together, I would add their rates together to create that equation. If they're going to work with each other, I'm going to add the rates together. And if we put them together, then together on the other side of the equation. Okay, now, can anybody think of a number that 10 and 7 would both go into? 70. Okay, so here's all I would do. Let me multiply this by, oh, what else do I need? I need a 70. What else do I need? X. Okay. Actually, let's just do it like this. This guy to make 70 and X on the bottom. I'm going to do X and X top and bottom. This one would need a 7. Sorry, I'm not going to multiply everything by. All right. This guy to make 70 would need 10 and 10, and then X and X. This guy over here has the X, but would need 70. So then if I do that, each denominator, 7 times 10 would be 70, 10 times 7 would be 70, and an X. So 70X in the bottom of all those fractions. So if I make those match, I can just work with the tops. Sarah's would be 7X, Amy's would be 10X, and then together we would just have 70. This is not a nice number here. So I get 17X is equal to 70. We're going to end up dividing 70 by 17. All right, so I got kind of a nasty decimal there. So this is going to take about, I'll go 2 decimal places, a little bit more than 4 days if they work together. You can leave it as a fraction if you want to, the 70 over 17, but I'm just going to write that's about a little bit over 4 days if they work together. Okay, let me scooch this up. Each one of these is just set up a little differently. Okay, so this says Matt can mow a lawn in 30 minutes. So I'm going to do kind of the same thing here because it doesn't tell you how big the lawn is or anything like that. So I'm going to let 1 represent the whole lawn. All right, so it says Matt, if my pen will work, the whole lawn he can mow in 30 minutes. Okay, now this one's a little different than the last one. It says if Matt and Sam work together to mow the lawn, it takes 18 minutes. So I'm going to just kind of slide down here a little bit. So together to mow that same lawn, which I just used 1 to represent that, it takes them 18 minutes. Then it says how long would it take Sam to mow the lawn if he works alone? So we don't know his rate. So Sam would be that mowing that same lawn, but we don't know how long it takes him to do that. So that's where your variable would be in his denominator. Now, same thing, I'm going to add these together because they're going to work together, and then that would equal the 1 lawn over 18 minutes. And I would, very similar, it's just the variables in a little different place in the equation here. What maybe would be a number that 30 and 18 would both go into? Think about that for a second. I think the smallest number I could do would be 90 maybe? Yeah, they both go into 90. Okay, so everybody's going to need an X, which this fraction does not have and this fraction does not have. And then 18 and 30, the common denominator between the two of them would be 90. So to turn 30 into 90, I'm going to go 3 and 3. The one in the middle here, we're just going to need 90 because we don't have any number in the denominator at all. And to turn 18 into 90, I'm going to need a 5 on the top and the bottom. 5 times 18 will give you 90. So the denominator for every single one of these then is 90x. If these all match, then we can just work with the tops. So we'd have 3 times x for the first fraction after we canceled out the denominator, plus just a plain 90, no x with that. And then on the other side, 5 times 1 times x would just be 5x. And I'm just going to subtract the 3x here real quick. So I would get 90 equals 2x, and then I'm just going to take 90 divided by 2, and x is going to be 45. So this would mean Sam by himself, if he was mowing the lawn, it would take him 45 minutes. Does anybody have any question? Okay, we'll do one more. Now this one's kind of weird because it doesn't give you a time for either person. So I'll show you how to set this up. Do what? Do what? Yes, it will be. Okay. It says Christine can shovel a driveway 3 times as fast as her sister Erin. If the two work together, it takes them 27 minutes. And how long would it take each of the girls if they worked separately? So again, I'm just going to let 1 represent the driveway. And you could literally use any number you wanted. You could use a variable if you wanted to. I wouldn't recommend that because that would make it more complicated. But we don't know how big the driveway is, how many square feet, whatever. So we just let 1 represent the driveway. Okay, so it says Christine can shovel the driveway 3 times as fast as her sister. So in terms of the time, one of the girls, I'm going to do 1 over x. And then for the other girl, we're going to do 1 over 3x. Working together, that's why I'm adding these together, they can shovel the driveway in 27 minutes. So then I can use that as the bottom. Okay, now, when I work through this, what do you think we should use as a common denominator here? 27 for the number and then x. Good. Okay, so top and bottom here, I'm going to need an x. I already have an x here, but to make that into 27, we're going to multiply by 9. And for this first fraction, I already have an x, but I don't have any numbers at all in that denominator, so we're going to have to multiply top and bottom there by 27. So now all my denominators would be 27x. So if we make them all match, we can literally just cross them out. So then this is actually a really quick equation to solve. This top of this fraction is just 27, plus the top of this fraction is just 9, and then the top of this fraction is just x. So then I end up with, let's see, 36 equals x. Okay, now 36 is x. For the other person, I have to multiply it by 3. So if I do 36 times 3, that's 108. Okay, now, as I read this, it says Christine can shovel the driveway 3 times as fast as her sister. So the faster person would have the smaller time. So she would be the 36 minutes. And she's 3 times as fast. So the other sister, Erin, is going to be a slower time. So she's the 108. So just keep that in mind when you're working these out. If you are doing something in a faster amount of time, it would be less time. If it takes you more time, that's the bigger number there. Is anybody having a question?